Ian.
Hello.
Is that correct?
It is correct. Yeah.
Okay, he flew all the way from London. Polyglot coding architect, founder of IDNUG. Is that correct?
LDNUG, yeah,
LDNUG.
London.NET user
Okay.
group. Yeah.
Okay, good. Speaker, tabletop, gamer, geek, has a little bit of tattoos, ear piercings, right?
Yeah, one or two.
Okay. Is there something I didn't mention?
No, that's probably me as far as everyone knows. I've got a good beard. That's the other thing.
Okay, well, hard to notice that. Yes. Anything else?
No.
Okay. How has been your 3 days?
It's been great actually to kind of to be on a plane again, to go and visit another place again. Build stuff's one of my kind of like parts of my year, and it's been a bit of a, last year was a strange year because there was no build stuff. It felt kind of like the year hasn't had a proper ending to it. There's no build stuff. But yeah, so it's been nice to get out and see people again. I say nice to see people, but we can't really because you're all behind a big halo of lights, like some sort of angelic host. So I have to hold my hand up to see you, but I'm sure there are people here, right?
There are.
They're waving at us.
Yeah.
All right.
We're blinded by the lights. And actually, if you will have any questions, I recommend you to put online, and we will have like a session after Q&A session. I am blinded by the light, so if you have any question, you just need to wave, or you just need to use your mobile phone. And Ian?
Oh, that's going to fulfill my rockstar dreams. If you all just use your mobile phones at the end to signal for questions, this could be the most awesome day of my life.
Okay, Ian, the stage is yours. Good luck.
Thanks very much. All right, folks. Someone pointed out to me that the talk is kind of advertised as managing event-driven architectures, and I've changed it to managing asynchronous APIs. It's not really different content. It's just probably a clearer explanation of what it is. That's my name on the front, and that's my Twitter ID. So if you want to follow me or ask me questions, my DMs are open, and I'm happy to take questions online. I know it's not always comfortable to ask questions of people in public forums, and I'm very happy to talk to people. Okay. A little bit about me. It doesn't say very much apart from the fact that I used to have more hair on top of my head and my beard was darker in colour. And I saw Jemima give a talk the other day where she described the ancient history of the web, which for me was a lived experience. It made me feel very old. But yeah, so over the time I talk about TDD, some people know me from, event-driven architectures, kind of microservices, and I'm also very interested and have been in the past kind of agile movements and clean code, etc. And I've worked for a number of different places over time. I'm currently at Just Eat Takeaway, trying to basically serve people food, which was pretty good in the pandemic for us. A point at the bottom I always draw attention to, right? I got kind of lucky to get into this gig of doing speaking. I started a user group. There was nobody who knew anything about the topic. We were of the user group to talk about stuff, so we had to do it ourselves, and I fell into it by accident. But it's been once you get over the nervousness, it's been fantastic for my career to have to explain my ideas and thoughts to people and practice doing that. And it's allowed me to travel around the world and meet lots of other developers in different countries, which is a fantastic experience. So I do recommend you do it. The people down here, we're not special, right? We're just the same as you. We just happen to take a different path. You could do it too. I also work with Toby, who's down the front somewhere. I can actually see Toby despite the light, on a open source application for .NET developers. We are a messaging framework. If you write in .NET, we will basically take messages off frameworks like Kafka, SNS, RabbitMQ, deliver them to a handler. So a bit like the same way you work with ASP.NET, but rather than HTTP and you're writing a controller, you just write a handler and we'll deliver a message straight to you. And we can use it as a drop-in replacement for things like Mediator, and we just work over an in-memory bus in that case. All right, what are we going to talk about? So I'm going to talk about the notion of endpoints. I'll explain what I mean by that. I'll explain why they're kind of important. And then we start to think about event-driven architectures, why we need to think about how we're going to represent those endpoints, be the best way of describing it. Then we'll talk about endpoint discovery. If we've got some endpoints, how are we going to find them? And we'll talk about why that's a bit of a problem. And then what we'll talk about about halfway through, hopefully, is Async API as a solution to some of the needs we've identified in the first half of the talk. And I'll run you through what a typical Async API document looks like, what kind of tooling they've got. And I'll talk a little bit about developments in the Async API community at the end to solve some of the issues that it has a specification today. So first of all, it might be a little bit useful, I think, for us all to get on the same page if we're going to talk about an asynchronous API to understand what I mean by asynchronous. But we may not all have the same understanding of that. So a synchronous conversation between two parties, there's a simple rule is that both parties are present at the same time, right? And in order for communication to be successful, they both have to be there. They're having a dialogue. And the simplest kind of example of a synchronous combination is a phone call, right? I phone somebody up, they answer the phone, we describe what we want, we have a dialogue, things get done, all right? The opposite for a synchronous conversation is an asynchronous conversation. Oh yeah, but the synchronous conversations have been well described by certain technologies, OpenAPI, GraphQL, gRPC, Thrift, so they're all examples of synchronous conversations. And a lot of that is documenting a particular approach to a synchronous conversation, right? So you can work with it, you can create tooling around it, that kind of thing. So an asynchronous conversation is one where both parties don't have to be present at the same time. Right? We can think about that really as a kind of mailbox, right? I send you something, it goes into your mailbox, be that electronic or physical. You can collect it at any time. You can think about your response. You can send it to me, and it goes to my mailbox, and then I think about it. So both parties don't need to be present at the same time because we can use store and forward to negotiate that. Okay. A typical example might be snail mail, or even any form of messaging app, like WhatsApp, Slack, an SMS, right? Nowadays, the only person that really phones me is my mum because, you know, she doesn't really want to use messaging apps. Everybody else sends me a message. Why? Because it's inconvenient to phone me up and I'm not there. It's frustrating. Whereas if you send me a message, even if I'm busy doing something, I can get to it in a couple of minutes and reply to you, right? I came over there on the plane with Toby, been chatting to him a little bit, but we've just been using WhatsApp the whole time. Others have phoned each other. And asynchronous conversations, in the same way that they are more useful for us day to day, when you think about your services you're building in your architectures, asynchronous conversations have exactly the same beneficial properties for you as a service implementer. If you don't have to have both your services working at the same time, if one can be down for maintenance, for a failure, then it gives you a much better operability, that's a hard word to say, for your services. Okay. But how do we describe them? Given we talked about all these standards for describing synchronous conversations, gRPC, Thrift, SOAP, DCOM, GraphQL, where are the ones that describe how our asynchronous conversations take place? Where are the ones that help us generate and build clients or infrastructure? And they've been kind of sadly lacking. All right, let's talk about endpoints. So WCF defines an endpoint for us. Now, WCF is an old .NET communications stack. It's long in the tooth now and was built really for the era of the web service specifications and SOAP. But it had some useful definitions, I think, that we can take forward for describing the kind of properties we needed to know about things. And it had tooling really around them. And it said endpoints are the places where messages are sent or received. So either party can use an endpoint. And it describes where messages should be sent, how they should be sent, and what they look like. And that latter part is often referred to as the ABCs: the address, the binding, and the contract. The contract, what I am sending, the address, where I am sending it to, and the binding, how I will send it. So if I'm going to send you a message, hello world, over via RabbitMQ, then what I would need to know is what's the schema of my message. It's probably just something that contains a string. I would need to know what protocol I'm speaking. For Rabbit, that's MQP 0.91. And I need to understand the address. So I'd need to know basically the location of your Rabbit server, basically. And that would allow successful communication. So those are the fundamental things we have to document to get messaging working. Switching kind of like tack a bit. Let's talk a bit about domain-driven design and what it says about communication. When we think about what we do as software engineers, we're typically modeling a domain. And domain is just the problem space. It's what we have to deal with. So right now, Just Eat Takeaway, I deal with the problem space of somebody wants to order some food from a restaurant, pay for it, and have it delivered to their door. Okay. And within that larger domain, we can think of subdomains. We can think of parts of that that are easier to reason about than the whole, and where people have particular expertise. So I can think about presenting a menu to you from which you can make food choices, offers and promotions from the restaurant, giving you basically a cart so you can see how much money you're going to spend and what the delivery fee will be and how long it will take to arrive. Getting feedback to you from the restaurant, sending orders to the restaurant so the restaurant can see what food they need to cook, right? All of those are probably what we would call subdomains. They're parts of the overall thing. And when we build software, what we do is we create a model. We create that model in the code, in schemas, in databases, and also in the language we use to communicate as a team with each other and with basically product owners. We create a model usually of part of the domain. We don't tend to model the whole thing, although a monolith is really an attempt to model the whole thing. We tend to try and model part. If we do it well, we tend to get an alignment between those models and subdomains. And that's really what microservices is striving for. Microservices strives to give you an alignment between those models and between subdomains. And we call that a bounded context, because the idea is that essentially within that particular context, your model has meaning and consistency, but not outside. So here we have, for example, two bounded contexts from my current domain. Restaurant availability, is the restaurant open? How long will it take to cook stuff for you? And restaurant management, someone signing up restaurants, adding them, generating all the data about them. Okay. And you'll notice that they both have a notion of restaurant. But what they need to know about restaurant is different. It's likely that restaurant availability may have a subset of what restaurant management needs to know and may calculate new information, right? So restaurant management probably sets up the hours that it's open, talks about basically what its cooking time is and its closing down time and its startup time in the morning. Restaurant availability may calculate new information based on that. So both of them have this same concept, restaurant, but they have slightly different models of it. So we don't have one model of restaurant throughout our enterprise. And that has some implications when we communicate. So we tend to think of communication between two parties as being between a customer and supplier. Why do we use that term? Well, the upstream and downstream help you here. So when somebody's upstream, I have a dependency on them. I need to get information from them. So restaurant availability depends on restaurant management. It needs to know about restaurants, right, and information about them. And the upstream downstream refers to the fact that if you think about basically two cities that live on a river, if the city upstream pollutes the river, the city downstream has to deal with the result of that. It has to, build filtration plants. It has to tell people to boil the water, etc. So we want to manage that problem space, that the upstream can damage the health of the downstream. So we say, well, let's think of it as a customer-supplier relationship. Okay. We'll tell the upstream, you're a supplier, and these are your customers, and you must be nice to them. And that comes through in the way that we might want to think about the communication between those two parties. So the worst possible world would be some kind of model of conformance, and that would say, well, restaurant management teams say, well, we have a model of a restaurant. It's kind of a superset of your needs. Why don't you just take that and use that in your code base? Just take ours. In fact, I tell you what, I've got a .NET assembly. You can just take that and use that in your project. And the problem with that, of course, is that if the upstream team change how a restaurant is structured, it breaks all the code in the downstream. Right? They'll have to basically recompile everything, fix the bugs. It's very unfriendly. And in microservices, we explicitly forbid this kind of relationship because that prevents what we call independent deployability. In other words, the ability for both of these teams to release without being concerned about what the other team wants to do. So restaurant management want to be able to say, we're going to change the way restaurant's structured. And if they release, they want to be able to release without restaurant availability also being forced to release because they have a copy of their code base. So what can we do? So one technique is called the anti-corruption layer. And the anti-corruption layer says the restaurant availability team decide we don't want to be impacted anymore by what restaurant management are doing. So we're going to build a layer, and in that layer, we will translate what comes from restaurant management, and we will translate it into the shape that we want to use internally in our subdomain, in our bounded context. Right? And by doing that, they defend themselves against changes to the upstream bounded context, because if the upstream bounded context change, they limit the damage to being able to fix the anti-corruption layer. And that's all well and good, but I still have a kind of a problem, right? In the sense that I still have to go away and change this anti-corruption layer, and there really isn't still a strong constraint on restaurant management not to break me. And if I have many teams that listen to restaurant information from restaurant management, you can imagine that someone like Just Eat Takeaway, lots of our services need to understand restaurants. Then obviously I'm implementing lots of these anti-corruption layers, and that can get operationally complex. So the other alternative is to tell restaurant management, well, what you need to do is define a contract for how you will communicate with everybody else. And that contract needs to be stable over time so that they can rely on the version of restaurant that you say you will publish. And we call that basically an open host service. What we're saying by that is we're saying, we're going to agree as an upstream team that this is the model of restaurant we publish. We're going to agree that that's going to be stable. It's not going to vary very much. And we'll try and vary it if we need to in ways that you can basically tolerate. We'll only add fields. We won't delete them, and we won't change the type of fields. And it means restaurant management can change the internal structure of their representations, provided they still honor the contract that they put out on the wire. Okay. And it means restaurant availability can say, well, we can listen to that message and take it in, and we can basically use it to feed our own models because it will be stable over time. And we can think about this as necessary coupling. Although, obviously, as software engineers, we understand the dangers of coupling. The danger basically is that things become complicated to change because the effect of that change ripples out everywhere. And we strive for loose coupling. We say, let's try and have these things as independent as possible so that changes over here don't have impact changes over here. And that's indeed the key to microservices, independent deployability. We must have some coupling at some point, right? At some point, if I've got two services, one is going to talk to the other for it to be useful. A service that basically doesn't talk to anybody else is probably never going to need to change, but it's probably also entirely useless to us. So we talk about this idea of necessary coupling, right? There's some coupling I'm going to have to do to make this work. And I would rather couple to things that are stable. Okay? Things that there's a guarantee and a promise that you say, I'm going to make this stable for you because you have to couple with me. And in order for me to provide a service to you as a supplier, I was going to guarantee you some consistency about what I supply so that you can take the risk of coupling to me because I won't change every 5 minutes. Okay. And if you've ever worked in an org where really people don't respect that in their APIs, you know how unpleasant it is an experience when you get a team that is continually changing their API in ways that break, releasing it without telling anybody else, and then kind of going, whoops, when effectively production goes down. So you really want to enforce this idea that I'm giving you a contract which you can depend upon. Okay. And like all contracts, it should be mutually beneficial, right? Both the supplier and the consumer can now benefit. And for anyone who's kind of familiar with the idea of promise theory, in promise theory, agents can make promises about things that they can do. And we can think of microservices, or what we call super agents, things that can make promises for a cluster of things inside them. And a service is effectively making promises. It's saying, here's things I promise to do. Here's the nature of my promise to you, right? And those are things you can agree to couple to. And so really, when we think about it, we take that definition of an endpoint earlier we gave, this idea of an address, a binding, and a contract, we can think really of the endpoint as being the necessary contract for the coupling that we're willing to do. Okay. So we're saying, yes, I'm going to guarantee you a message with this schema and shape. I'm going to tell you that basically it's available on these protocols and you can talk to me in this way. And I'm going to tell you that you can basically get hold of it through this address. Right. So, endpoints, where messages are received, where messages should be sent, how they should be sent, and what they look like. Okay. How do we discover these endpoints? I've understood now that I want to document the endpoint somehow, right? But how am I going to do that? If I'm working on, the restaurant availability service, and I know I need to talk to restaurant management, or I need to get information about restaurants from somewhere, where does it come from? How do I find that in our org, right? And that's a real problem in some orgs, right? Because typically an answer is someone says to you, why don't you hop on the big Slack channel where everyone hangs out and post a message and say, hey, anyone know who publishes restaurant management messages? I'm writing a new service that needs them. Or the other alternative is you go to your GitHub and your enterprise and you say, maybe if I type in like restaurant created, restaurant updated, and I search all the repos, I can either find somebody that's using it or I can basically find who produces it. Anyone had that experience internally at their org? That's how they basically find services? Yeah, a couple of you. All right. And that's a bit of a pain, right? And if we think about the owner of a message, even though in a pub-sub world we like to be loosely coupled, so we like to say, I shouldn't have to know who my consumers are, they should just better subscribe to my messages and start taking them and doing their work. There can be times when it's useful for us to understand who they are. Let's say I need to make a breaking change, right? A common one we see is somebody has somewhat foolishly coded their ID of their thing as an integer because they built it in some identity column in a SQL data store. And now we've realized it doesn't scale very well. And could we have a string, please, so we can use it in something like a key value store instead? And so someone's got to say, well, I have to change the type of the identifier from a string to an integer. How am I going to go about that? So I need to communicate sometimes with my customers. How am I going to find them? Because generally the answer in a lot of orgs looks very similar to the one we've got today, right? I go on Slack channel and I say, anyone using my service? Or I start searching repos, say, well, I create the message that looks like this. Someone's got to be using it, right? And that's not very effective because generally my experience is when people do that, somebody gets missed. Typically, people who manage the data lake get missed. They're listening to all these messages floating around the ecosystem going, we're building our data lake, and everyone forgets to search their code base because that's the data team. When they change their messages, they break that. Okay. When I think about the message that I'm sending, there's things I might like to know about it, right? What's the content type? We sending JSON, text, XML? Are you with the XML fans in the organization? We send that type of content, right? Is it encoded? We sending plain text, or is there some kind of binary encoding to reduce basically the size of it? What's the schema? It's a contract. So really, I should probably be able to determine the schema in the message and it ought to be consistent, right? What about the metadata? Messages just aren't about the payload, they're about metadata. I may find useful things in the metadata, like correlation IDs. Correlation IDs can be useful for me to understand, does this message relate to something I talked about earlier, right? It'd be very useful for me to know that was in the header. What about the protocol, right? I know that you expose a message, but what over? AMQP, HTTP, Kafka? How do I talk to you? So we need to understand and document all these things if we're going to succeed at communication. Okay. So that gives us a chance, I think, to define a set of requirements that we might have for describing our endpoints, right? So we understand that we know what we need to know. Messages should be sent, how they should be sent, and what they look like. So obviously we're going to need to have a message. Whatever definition we choose needs to have a message, and it needs to have a header and a payload. Right? It needs to be able to support those two key ideas. It needs to go over a channel. So a channel is a logical pipe in messaging, right? It's this idea that there's a logical pipe which connects two systems. You can think of it, if you know, in messaging systems, like a topic in Kafka, a routing key in RabbitMQ, or a topic in SNS. Topic's a really common name for it. That's a channel, something I can logically address. That's why I send my messages over. And my channel probably has some kind of binding, because I need information about that channel specific to that protocol. And in theory, I might actually make that channel available over a number of protocols for different consumers. So given that, do I have other solutions out there to basically documenting my endpoints in this way? So Async API as an initiative, I kind of came across it, I guess about 18 months to 2 years ago, but I think it's been around longer than that. I don't have a date for you. They've recently joined the Linux Foundation. So they now have an open governance model, and generally it's run by, there are key contributors to the project, and then there are a whole bunch of committers, right? I mean, it's a very open community, it's very welcoming, and some very smart people inside it. And you can go and join there. They have a Slack group, and they have regular kind of, they have in your Google Calendar, you can put a regular meeting, you can catch up and chat with everybody. And what they give you is a specification. A specification says, how am I going to describe an endpoint? And their starting point originally at one point was they liked the way that OpenAPI made it very simple for them to describe some HTTP endpoints, and they wanted something similar to describe messaging endpoints. Okay. And what they do is effectively provide a specification and a parser for documents written in that specification, and then provide some tools built on that, right? So that's that code generation element above. And I think it's a really useful tool. It's not quite there yet, I don't think, in terms of where it will eventually need to be, but I think it's good enough to use at this point, and hopefully we'll get some of the things that are a bit niggly fixed going forward. Let's wait those towards the end. So the model in Async API is that you have an app, and your app kind of has a role. And really your app could fall into one of these three roles. Mostly it could be a producer, sending messages. It could be a consumer, could be eating messages. And where you're point to point, rather than publish subscribe, it might be a server, right? It might be saying, I actually exposed the API directly myself. In a broker-based topology, your broker is the server. At any given time, any app may have both these roles, right? Because if you think about a typical app, it has kind of an inbox and an outbox, right? Some work requests come in via its inbox, it does some work, it puts the results of that work on its outbox. So it's acting both as basically as a consumer to consume work coming in, and a producer, it's producing stuff that goes out at the end of the day, right? So these are really roles that you can have. And over that, what it needs to send is a message, right? And the message needs to have a payload and a header. And it sends it over a channel. And the channels are hosted on the server. And it has a notion basically that there is a protocol which is attached basically to the channel, and it uses an idea of bindings to say, oh, is there protocol specific information you need attached to channels, to servers, or to messages? And protocol specific information attached to messages are the required headers on this particular piece of middleware. And its diagram gets complicated after a while, it's a little bit simpler than that. But it therefore seems to fulfill a lot of the needs we are describing earlier, right? So what happens is you write a JSON or YAML document, depending on your preference. I secretly still like XML. You can shoot me afterwards. But that's not an option. So basically you write it in JSON or YAML. What happens is you have a top level or root object called the Async API object. And really that doesn't contain very much apart from an ID saying what is the app that I'm documenting. So you document apps. Below that you had an info object, which is the metadata about this particular application that you're documenting. You have a servers object, which basically says, well, okay, where would you go effectively to try and consume or produce the messages effectively that are here? It has a channels object, which says what channels am I actually using, and it has basically within the channels object, it has channel items and operations. So operations basically say I'm either publishing something or I'm subscribing to something. We'll come into publish and subscribe in a little bit because it's one of the more confusing aspects that needs to get fixed. And then it has components, and components really allow us to take common definitions like with message bodies and that kind of thing and put them in one place rather than keep repeating them in the rest of the body of definition, and tags, which are obviously user-defined name value pairs that we can use to identify additional information that we want. There are extension points throughout this in the sense that you can add your own X- properties to certain areas like info objects, and bindings are effectively an extension to a number of these items. This is what an ID looks like, right? It's just a URI saying what is the app that I'm talking about. And this is an info object. So it's got some contact information. That's pretty useful, actually. Who is the person that I can talk to about this particular app that's being documented here? Licensing information, which is probably a bit strange internally. A description of the kind of the app and what we're doing, and any tags that are important to you. And there's one you can extend. I quite often see extended with a lot of X- information for your own corporate needs in terms of visibility. A servers object, which, as I'm sure you can imagine, is just really tells you where the servers are. You can have a number of these, so you can basically support multiple environments like, production, QA, staging, depending on your needs. Here I'm defining one as this is my local one that I'm using, for example, so that essentially you can work with those. And then you have a channel. So this channel here is the greeting channel, right? And what I'm going to do is let you send or receive greetings to the channel. So Brighter has a lot of sample apps for various combinations of what we call a transport, like Kafka AMQP, and generally speaking, a lot of our examples use the idea of sending a hello world message between producer and a consumer, right? Because it's nice and simple. So the conceit here is basically that I'm documenting a Brighter example, and the idea is I've got a channel called greeting over which I'm going to send a greeting, right? The operation ID is not so useful. It's mainly meant for code generation, so that you can say I want to basically generate a method called send greeting where I effectively will deal with this. Now, there are a couple of interesting things to talk about. The first thing is publish and subscribe. So the way that Async API was designed was the idea of an API that you are using. So it exposes the operations that the API supports. As a result, the subscribe operation means you can subscribe to this channel. In other words, the producer exposes the subscribe operation. And the flip side of that is, as a consumer, I expose the publish operation, because you can publish to me. That has caused much pain because it is counterintuitive, and that's one of the things that's going to get fixed. I'll talk about that in the VNext bit at the end. The other thing that's interesting here is you can see the $ref symbol. And $ref really is applicable in a number of places, and it lets you say, rather than this part of the spec, put in the whole message schema, which may need repeating in a number of places. What I'm actually going to do is just basically have a ref, and I'll put it into a comments block. So refs can be of two forms. This form says it's inside the same document, just uses the page fragment syntax and says you can get to my message schema inside the components section of my specification. And this form says actually it's in a separate file, and you go to the separate file and you'll find a components section with has the greeting in. And the latter, the bottom one, is useful where essentially you both want to say, well, I am a producer and I am a consumer, and we are both putting a message over a channel, so we share the definition. And so between the two of us, we'd like to have that in a common file somewhere where effectively we just both refer to it, rather than redefining it in producer and consumer and risking that essentially those definitions get out of shape. And then the component section effectively will give us then the message and the schema. So you can see a simple message here called greeting. It has some properties around what the message is and does, and then effectively it has a traits and a payload. The payload you can see here down below in schemas. Effectively, it's just saying I've got a string which gives you a message like hello world, etc. Traits I haven't got here because of space, but traits let you define common properties that essentially you fold into something like a message, and typically they're used for things like header values that you want as an organization all of your messages to support. And so we can think about now, what does this map very well to our requirements? Well, certainly the Async API object basically you can think about basically as being, hey, we've got some documentation for our endpoint. The info object is certainly a bit like, a general description of an endpoint saying, hey, we offer some services to you. But particularly when we get into channels, what's interesting is that these notion of operations, exposing things like publish and subscribe, feel a bit more like the way that endpoints say, I'm exposing a set of operations that you can perform upon me, less than anything to do with messages, channels, and bindings. The operation object itself holds message, which is kind of a bit strange, right? Which is kind of the key thing we need to tend to have for a contract. And the service object and the channels object between them seem to represent something that represents channel. So it's a little bit awry from my specification. And the reason for that is that essentially it began life as a kind of port of open API to help deal with WebSockets. And this is one of the things I think that you'll see change, is you see a better alignment between the left and the right. A little bit. And binding information can stay in any number of these places. So you can have then components, objects, and tag objects. So it models point-to-point better than pub-sub, basically, today. I can actually show you, if I flip the screen, will it work? No. Do I have to end the show to flip the screen? That'll do it. Do I get the display that? Do you see anything? Nah. I don't know how that'll work. Is there a way of seeing that screen, my screen? No? All right, I got a slide. We'll do it with a slide instead. Right. So, what tooling helps you with this? So there are designers that will help you write Async API. This one is Async API Studio. It's kind of the newer one. You write your YAML or JSON on the left-hand side, and gives you basically kind of a nice HTML version of how that looks. Async API Studio is a newer version of something that used to be called Async API Playground, which you can see there. And there you can kind of see a bit more, which I was thinking of trying to flick to show you. That's basically a slightly fuller representation of all those pieces I was showing you as a file, right? That's what an Async API file looks like. Okay, and you can also, as a VS Code plugin, because everything in the universe now has a VS Code plugin, and you can see effectively there you've got a VS Code plugin which does the same work for you, right? And there are also tools out there like Spectral, which will help you basically do things like linting Async API specifications. And Async API support is becoming supported in a number of places. One of the ones that's most interesting perhaps is Backstage. Who knows what Backstage is? Only a few of you. So Backstage comes out of Spotify. It's essentially a place for putting developer-facing documentation internal to your org, rather than writing it all yourself. It can be worth having a look at Backstage and seeing what it offers you. Also offers you places to do things like run scaffolding and tooling, to build for the first version of your new microservice that's compliant with all of your internal enterprise standards. It's a pretty useful tool. And you can see Async API is one of the supported standards, basically. There are tools emerging from the Async API community that look useful, although I think they are still early days. This is one that's quite interesting called Cupid. What Cupid will do is have a look at the flow of your application and the nodes, etc., effectively, and where they go. And to use our endpoints, there's quite an interesting kind of process. So what happens is you get a parser, and the parser basically turns your specification into JSON. And effectively, you've got this JSON that's shredded and turned into an object. Once you take that, you can push it towards what's called a generator, and you can use the generator to generate any kind of new file for you. It basically relies on templating in either React or Nunjux. So you provide your template, you pull in all the facts that you've got from essentially breaking down your Async API document, and you spit out something new. So what have I done here? Let's put some text on because that's easier than that. Okay. So this is essentially what the React template would look like for, say, for a simple example of us trying to decide that we want to basically take information on what all the Kafka channels that we have are. So we basically export a function, and in that function we're just saying, let's read through the Async API specification, which has been returned into JSON, and we're looking basically to see if there are any channels that are marked as publish. In other words, we're a consumer rather, and we are effectively allowing someone to publish to us, and they have a binding of Kafka. So those are the Kafka channels we listen to, and we spit out a list of that. What could we do with that? Well, we could use that to generate infrastructure, or we could use that to generate basically client code. So documentation, typical use case. Take basically specifications, spit out some HTML. That's essentially what's happening in some of that tooling you've seen earlier. Infrastructure as code, something we're looking at right now. The idea of effectively taking basically their binding information and using it to actually create the relevant infrastructure you need for messaging. So creating all of the queues, etc., that we need to do that. And scaffolding, right? The ability effectively to spit out code. You can spit out code to describe basically, here is a handler that will consume that message essentially, and then you just need to go and write whatever your domain logic is in response. So it's quite powerful once you begin to think about the tooling opportunities for writing consumers of given messages. All right, last up, basically talk about vNext. So as I mentioned, one of the concerns in the community has been that the initial requirements were very much based around point-to-point. So by point-to-point, I mean there's a producer and a consumer. They might both act as server and client at different times, and they're exchanging information. As opposed to pub-sub, where there's kind of a broker involved, and I'm tending to basically publish messages to a broker and receive them from that. So what's likely to happen is these are just kind of like pulled from some of the GitHub issues where people are talking about ideas for it, is there's some movement around where things are. It's quite likely that operations which currently live under channels and channel items will move up to be an independent item, and they will tell you to solve that publish and subscribe problem. I am an operation that's doing something like sending or receiving, and I have a given binding, right? And the message will be tied not to the operation, in other words, my desire to send or receive a given message, but to the channel. And that makes a lot more sense to me. I think we'll get a much clearer definition of address, which is the server, the contract, which is the message living on a channel, right? And then really this idea of some kind of operation at the endpoint that I'm performing, which is either to send or receive on that. So I think that work is under discussion and quite advanced, but I would expect to see something sooner or later that basically bears fruit out of that, which helps make pub-sub a little bit easier than it is today. All right. And that is that. Okay. Thank you very much.
Thank you. Do we have questions?
Or does everyone want to go home? Oh, look, there's a question.
Okay.
He didn't use the phone light. You destroyed my rockstar dreams.
Yeah, we have agreed.
Thank you for the topic. I have one question related to the business flow that may be connected to our descriptions. As I said, we may have synchronous and asynchronous communications, right? And in general, when we design our system, we are talking about the business flow that we are going to implement, right? And there are some techniques that may help us to visualize and connect our product with technical department. For example, event storming, right? And we may use Open API and Async API to describe our endpoints. However, we still need to connect our business flow and technical implementation. Could you recommend any tool or technique that can combine this technique that describes business flow and technical documentation?
That's a really great question. So the question is, we describe endpoints, but what about the flow of messages that basically make up a given kind of operation in response to a consumer request or some kind of supporting request? And the reality is today, Async API doesn't really help you with that because it doesn't describe a series of sequence of steps. I don't think there is a good answer today. Certainly not seen one. The Async APM community has been talking about it, and Clemens Vastas has kind of challenged the community. Basically, he's the architect behind Azure Service Bus. That's a hole in what Async API does that desperately needs filling. There are some people who in the Async API community who've looked at a specification for kind of step-based workflows that they are trying to use to solve that problem. I don't know necessarily that that's the right answer because they're kind of treating it as a state machine. I don't know that's actually what we want in all cases. But yeah, I think it's a problem, but I don't see anyone as having a very clear way of currently representing that kind of flow that occurs when we want to create meaning between a source and a sink and a number of steps in between and talk about what happens if things get cancelled or fail, and particularly the failure paths. And yeah, I'd say that in lots of enterprises today, one of the problems is people don't understand all the possible paths that can happen. And the result of that, it means failure can be likely and quite often can be unexpected in what actually happens at that point. But yeah, I don't have a good answer today. I think the Async API community is aware, but hasn't yet got a proposal in kind of the V3 timeframe, which fixes that. You can have a look. There's a, I think it is in the Async API repo. There's someone basically proposing this kind of step-based approach. I don't think it's there yet, but have a look. Anybody else?
Do we have more questions? No. Let's wrap up. So thank you again.